Greetings and welcome, friends. Yesterday we were talking about verifying trigonometric identities. Yes. And we're on page 434 and looking at some of these problems where I'm trying to verify these. The general approach is I'm trying to get the left-hand side to equal the right-hand side. It technically doesn't matter if I do a little work here and a little work here. If eventually I show they're equal, then I'm done. That's the goal, okay? Now, the technique will vary. I'll be using my trig identities that are previously known to us and kind of interchanging values with substitution. I might also use some techniques from algebra of dealing with fractions or factoring or different things like that as well, whichever might be helpful. So let's take a look at problem 6 here. I've got 1 over tanks plus seeks equals cosks over sinks plus 1. Okay, so now this is a situation where I've got a fraction equal to a fraction. And I'm actually a little curious. I might try a cross multiplication strategy in order to try to just get rid of the fractions. Okay, another technique, I mean, I could start tinkering around with changing these to sine and cosine, but I have a feeling that's going to get me confused. But let's cross multiply just to see what happens here. So sinks plus 1 times 1 would be sinks plus 1. And that's going to equal, and I guess I'll distribute it by both of those. So that's cosks tanks plus cosks seeks. All right, so I've just multiplied the cosks by both of those, distributing it like. So let's see. Now I've got cosine, sine, and cosine. Maybe this is a good place to replace everything in terms of sine and cosine. That was another general approach that could sometimes be helpful. So I could replace tan in terms of sine and cosine using a quotient identity. All right, so quote tanks would equal sinks over cosks. All right. And seeks, I could use a recip identity, right? So recip, and I have secant x is equal to 1 over cosks, right? So let's replace that and that, right? Something like that and that. And let's see if that helps us. Let's see what that does. So this left-hand side I'm going to leave alone for now. So I'll have cosks times sinks cosks plus cosks times 1 over cosks. Oh, and I'm thinking this is looking good, guys. What simplifies here? Yeah, those cancel out, and those cancel out. And it looks like I'm going to get sine x plus 1 is equal to sine x plus 1. Right, so ditto marks there if I want that. So yeah, verify. So in this case, I had a fraction equal to a fraction. Sometimes just to deal with the fraction aspect of it, being able to cross multiply can be helpful. I mean, unless somehow it seemed blatantly apparent that I could replace this with somehow show that that was equal to sine x plus 1 and show how the 1 was equal to cosine x, but I don't think that would happen. So we're good. There's problem 6. Let's take a look at another. Problem 15 here. Secant x minus tan x is equal to 1 minus sine x over cosine x. So let's see. So I've got a fraction situation, but it's not a fraction equal to a fraction. I mean, I suppose I could put this all over 1 and try the cross multiply trick. That might be interesting. I don't know. But I'm actually intrigued more on the idea of kind of dealing with this as a, if you think back to our rational equations skills, in kind of getting an LCD and all that. But I think I'm actually going to use exactly the same identities. I'm going to go with replacing these in terms of their sine and cosine counterparts. So for secant x, that's going to be a reciprocal identity. That's the same as 1 over cosks. Tan x is the same as sine x over cosks equals 1 minus sine x over cosks. Right. So that was a recip and a quotient identity. Question?
Yeah, I completely dismissed that first part. How are you able to pull that 1 out of that fraction?
This one? This one.
Yes.
I've replaced the secant x with 1 over cos x.
Oh.
So that's where that 1 came from. And then the tan x I replaced with the sine x over cos x. All right, so it was just a substitution that this became that and this became that is what I did. So now, a couple things you could do. You could realize that, hey, both of these fractions have the same denominator, so I could kind of combine them over a common denominator. And that actually would give me this right away. Or this is maybe the more complicated way, but notice I have multiple fractions here. What is the LCD between all of those fractions? Cos x. So I could kill all the fractions by multiplying both sides by the LCD. All right, which even though there's that easier way I just mentioned, this LCD technique I just want to show you so that way we kind of have it in our toolbox so we'll know how to do this when other problems might require it just to get the practice. So if I multiply the LCD by both of these, cos x, cos x cancels out with cos x, leaving just the 1. Here they would cancel out, leaving the minus sine x. And here it would cancel out with cos x, leaving 1 minus sine x. And that would be verified. So like I said, that's not the only way you could have done it. You also could have just had both sides equal to this if I just combine those as a single fraction. But yeah, so once again, this problem ended up being solvable using rewriting everything in terms of sine and cosine. And sometimes that is helpful for sure. Let's look at one more. So here we are, problem 17. Secant x times cos secant x equals tan x plus cotan x. Boy. Now, I want to point out, I see nothing squared here. So that's why I'm kind of steering clear from the Pythag stuff. I'm interested to see what happens when I rewrite this and this in terms of sine and cosine. I'm intrigued. Maybe? Actually, maybe should I do all of them? What do you guys think? Should I just go all the way? Probably. Well, actually, one of the benefits I have is I could just work on the left-hand side a little bit and then see like, oh, maybe I should do this on the right-hand side. So I don't actually have to write anything over here, for a few steps. And I could just kind of tinker at this left side until something happens. So secant x is the same as 1 over cos x. And cosecant x is the same as 1 over sine x. So that's the same as 1 over sinx cos. Right? Okay. So I think I've kind of dead-ended on this side. It might be valuable for us to rewrite these, I'm guessing, in terms of sine and cosine as well, using their quotient identities. So I'm kind of substituting everybody here. So tan x is the same as what now? Sine over cosine. And cotan x is the same as? Okay. So looking at these denominators, because I can't just do the cross multiply thing because I've got a plus sign. Looking at these denominators, what is the LCD? Well, it's got a sine x in this one and this one, so I need to have at least a sine x. And it's got a cosine x in this one and in this one as well, so I need to have a cos x. So there's my LCD. Let me actually, I'll rewrite this. And I'm going to multiply both sides by the LCD in order to kill all the fractions, or their denominators anyway. And I've got a good feeling about this. Multiply by LCD. LCD over here as well. Over here, the LCD would just cancel out completely with that, leaving what on the left-hand side? 1. And let's see, over here, now this LCD is going to be distributed to both of these fractions, mind you. So this guy's being multiplied by that. The cosines would cancel out, and I'd be left with sine x times sine x, which is Yeah, or sine squared x, technically a little bit more specific. And over here, the sine x would cancel out with the sine x, leaving cos times cos, or cos squared x. And you might recognize that as a Pythag. And I agree, and I'm going to get 1 equals 1. Verified. Right, because the Pythag identity literally said sine squared theta plus cos squared theta equals 1. So I could just substitute 1 in for that. It's kind of a gross arrow there. Well, anyways, but you get the idea. So, so that's the general strategy, is just kind of tinker around with these. Use some of your fraction skills like cross-multiplying or multiplying both sides by the LCD when necessary. And then just kind of realizing what you can switcheroo and work at it on the left side, work at it on the right side, see if you can find some common ground where you can make them equal to each other, some sort of a compromise almost. All right, thanks for watching, friends. Bye-bye.